Welcome students to this new chapter, and name of the chapter is Principle of Mathematical Induction. So what is this big name? We'll come to that later. Now let us just look about logic for some time. Actually this chapter is more or less based on logic, and I want to introduce to you two types of logic, and that is one is deductive and one is inductive. So let us go to deductive type of logic. What is that? Suppose I'm giving you a shape. Okay, this is a shape, whatever it is, and I'm giving you some information. That is, all the sides are equal to each other. So all the sides are equal to each other, and then I'm giving you another information. That is, all the sides are perpendicular to each other. So that means all the sides are perpendicular means all are 90 degree. Okay, so what will it be? So based on these informations, first information, all the sides are equal. Second information, all the angles are 90 degree. Okay, because all sides are perpendicular means all the angles are 90 degree. So what shape is this? Now because of these two information, we can say that this shape is a square, right? See, if it was all the sides are equal, it could be a rhombus also. But if so, if we say all the sides are perpendicular to each other, if that was the only information, we could say it could have been a rectangle, because in rectangle also all the sides are perpendicular. But only in a square, these two things come together. All the sides are equal and all the sides are perpendicular. So we had fact one fact, and we had another fact. Based on these two facts, we reached a conclusion. We made a we reached something, we told something, or we could find out something based on the information or the facts that was given to us, right? That is deductive logic. That means some information is given to us, and from that information or informations, we are finding out something, and it is always true. It will always be true. Now, another type of logic is inductive logic. Now, what is inductive logic? Look at this. Wow, there's a plate containing sweets, and you know, the moment you saw it, you were so excited and you wanted to eat it. So you took one and you ate it, and it was horrible, horrible. And you were like, oh man, this is not gonna be good. But you still wanted to try out another one. So you took another one and you ate that. That was poor, horrible, really bad. And but then you still like the sweet, so you still like the type of sweet, so you wanted to try more. So you say, I'll try this also, and that is extremely horrible. Now, students, suppose you had a plate of sweets like this, and you ate 3 of them, and it is horrible. Without eating, you will say it is not good, right? Without eating, you can say, I know, without eating itself, I know this is not good. You will say, right? So it is like you go to a restaurant, and you order something, you get bad food, and that happens for 2 or 3 days every time you go. Then you will, in your life, you will never go to that restaurant, right? Because you will think that every time they will serve bad food. That type of logic is inductive logic. So what is that? You observe some cases, something, you observe what happens. So in this case, we had case 1, case 2, case 3. Number 1 case, first sweet, second sweet, third sweet. You observed all these 3 sweets, and you saw it was bad. So you, based on these observations, you reached a conclusion. All the sweets are bad. Without eating all the sweets, you said that all the sweets are bad because you observed 3 out of the 7 sweets that was there. Now, is this always true? Not necessary, because it could have been good. Maybe that there would have been that magical that there could have been that magical sweet which could have been good. We don't know. But most probably in our life also, when we buy things also, we apply the same logic. So most probably it is true. Most likely true. Most likely, because if you tried one, it is bad. Second case you tried, it is bad. Third case you tried, it is bad. So most likely, oh, everything is bad. So that is inductive type of logic. Okay. Now we have used inductive type of logic already. Let me remind you of one of the cases where we used. Look at this sequence: 1, 4, 9, 16, 25. Now what will be the next? So let me think. 4 is 2 square, 9 is 3 square, 16 is 4 square, 25 is 5 square. So sir, the next one will be 6 square, and that will be 36. Yes, it is. And what will be the next number? That will be 7 square, 49. And yes, it is. But how were you able to find that? Did I tell you the formula? Did I tell you it is a square series? I didn't say anything. But based on these observations, or based on these cases, you made some observations. What was the observation? These are: 1 is 1 square, 4 is 2 square, 9 is 3 square, 16 is 4 square, 25 is 5 square. It was an observation that you made from the given details or from the numbers that you got. I didn't give you any information, but without I giving you any information, you made an observation that these are squares. So therefore you made a conclusion that next number also will be a square. Next number will also be a square. That was your conclusion. And it is true. But it could not have been true also. For example, I could have written here some other number, and you could not accuse me of anything. You cannot say, sir, you did wrong. You cannot, because I can make my own series or own sequence. So most likely it can be true, but it is not necessary to be true. Okay. Now, what we are going to do in this chapter is we are going to bring these two logics together, and we are going to apply a test, and the name of that test is principle of mathematical induction. Okay. So with this principle of mathematical induction, we are going to prove things. We cannot always use deductive because we need informations. Suppose we don't have the information, then we have to make observations. So we need to see and okay, so this is what happens. Okay, so we need to make observations, but making observations and concluding from that is not always a good idea. So we need a mixture of deductive logic and inductive logic to make it solid proof, and that is what is principle of mathematical induction. Okay, and so that was just the introduction. I mean the pre-introduction. So in the next video, we will just jump into what principle of mathematical induction is all about.